Biological specimens which have been chemically fixed and dehydrated with graded steps of ethanol may be transferred to a xylene solution and then infiltrated with paraffin. Here, a commercial product, Paraplast, is being dispensed from a heated reservoir into vials containing the specimens in xylene. The vials are stored in an oven where the paraffin infiltrates the specimens and replaces the xylene. After several changes, the specimens are in pure paraffin embedding medium. Some fresh paraffin is dispensed into plastic molds and kept warm on an electrically heated table, and thus in a liquid state. The specimens may be removed from the oven and poured into an open Petri plate where they remain in the molten state. Individual specimens are then selected and transferred singly into the molds. The molds can then be examined under a dissecting microscope where proper orientation of the specimens can be made. This allows for later sectioning to represent a particular plane of observation. An extension plastic mold is added which permits additional paraffin to be poured. The assembled embedment is now transferred to an ice chest in which the paraffin is set and hardened. Sections of paraffin-embedded specimens will be cut using a freshly honed metal knife. The honing, or sharpening, is accomplished by a mechanical device that automatically runs the blade in an abrasive paste until the edge is ground as sharp as possible. The knife is cleaned and then inserted into a sectioning machine called a microtome. And now the hardened paraffin embedments are trimmed with a fresh razor blade so that excess paraffin is removed and the block is shaped somewhat like a truncated pyramid. Careful trimming is necessary for further orientation of the specimen and for good quality sectioning to take place later using the microtome. After all four sides are trimmed, the specimen is inserted into a chuck at the end of a cutting arm on the microtome. Thickness adjustments are made, and the operator now aligns the specimen with the knife. A nearby vaporizer provides atmospheric moisture to prevent static electrical charges from causing the sections to be lost. Each time the arm containing the specimen moves up and down, it also advances a small increment, thereby providing the movement needed for making a section. The individual sections stick to one another and comprise a ribbon of paraffin sections, each with a slice of the specimen. Using fine-tipped forceps, the operator removes a ribbon of sections and cuts them on a clean surface. A clean glass microscope slide treated with an adhesive is flooded with a dilute formalin solution on which segments of the paraffin ribbon are floated. The ribbons of sections can be placed in a particular order so that serial sections can be traced. The slide is then placed on a warming table to evaporate some of the fluid and to help the sections adhere to the glass. After a period of time, the excess fluid can be blotted off with a tissue. Additional blotting is performed using a bibulous paper that absorbs like filter paper. After drying, the slides are now deparaffinized by placing them into a Copland jar of xylene for a set period of time. Subsequently, the slides can be run through graded changes of alcohol and into water for hydration and for staining. After staining, a permanent mounting medium can be applied to the sections, a cover slip added, and a small block weight added to flatten the layers during drying. After drying at room temperature or on a warming table, the slides are permanent and ready for observation with a light microscope.